ఎలా ఉంది వాడికి ఇంట్లో అప్పుడే పక్క వచ్చుకున్నాం.
అండి ప్లీజ్ మ్యూట్ చేయండి, మీ మైక్రోఫోన్స్ మ్యూట్ చేయండి. Hazard control measures we have seen here, use of PPEs, electrical work procedure, that is the method statements or the SOPs, work permit system, training and education, resuscitation techniques, first aid and firefighting, then electricity cause of accidents or incident. The main causes of incident with electricity is defective or inferior machines, appliances and cables, poor or missing earth connection. Now here, even in our houses and other things, appliances, if we see, we either remove the earthing prong from our sockets, or we don't have the electrical earthing system within our building. So that is one of the main reason. Incorrect installation and assembly, improper use of electrical installations and materials, carelessness and ineffective, inattentiveness and ignorance, direct or indirect contact with the live parts. So these are the main causes of electrical accidents or incidents. Now, apart from that, the electrocution, that is the death by electricity conducted through the body. That is what we say electrocution. The other things that can happen when you encounter the electricity can be wounds due to spark or arcs, injury due to electrical shock or reaction to the shock. Now here, injury due to the shock is if you contact with the electricity directly for a period of time. The reaction is the reflective action when the person contacts with the electricity. Like, if you contact with the electricity, the hand automatically goes back. So that is the reaction from the shock. Then you have the risk from fire and explosions. Yes. Then determine the factors of injury. The first factor for injury can be the route of the current takes through the body. As we have already seen in our previous class, the path of the current that takes causes the injury. The amount of voltage and related current intensity. We have seen the voltage and the amount of current in amperes, how much it is dangerous to us. Duration of the current passing through the body. The lesser duration, the lesser injury. The more duration, it can lead to a death. Then the physical condition of a victim. Here, physical condition of a victim means the dry, as we have seen, the dry skin is more resistant and the wet skin is less resistant. Moreover, the physical build-up of a person also determines the electrical resistance. And as I've told, even the gender, male and female, have different resistance to the current. Now here we have two types of current, that is direct current and alternate current. Plus and minus are constant in direct current. So the direct current flows in one direction only. Larger arcs in the event of short circuit. Now here if you see, this is the diagrammatic representation for direct or DC currents. Now for alternate currents, all our appliances, if you see, especially our inverters, You can see this particular sine wave on that. So AC currents are more dangerous as compared to the DC currents. Plus and minus change very quickly. This is why we say it is alternating current, because the poles change very quickly. So the alternating current flows back and forth. That is, here you can see within the graph. Then usually it is more dangerous to the human body. So AC currents are more dangerous compared to the DC currents. Like in last example, we have taken the charger example. It gives DC current 5 volts, but the amount of current that it discharges is very high. Now here in this, I'll play a short video. Now this is from the live recording of some place. Just see this. That is why for HSE or safety officers, before going for excavations, he should have a checklist. In the checklist, he should have a clear mentioning of underground utilities. Now, these underground utilities can be gas connection, electrical lines, either it can be low voltage or high voltage, or even the sewer lines or the water lines. So just watch this.
How dangerous excavating can be when you don't know what might be underground. These guys obviously know how to run. Frankly, it's a dangerous situation. Just look at the propane tank, which was close to the explosion. Water utility workers cut high voltage cable while doing their job. They also created extra room for electricians. And now they must call the electricity company to fix the problem. During the road lighting war, excavator operator cut the cable and let the city to power outrage. People in Russia are amazing. Just look at their calmness. Nothing bothers them. They will go about their business. A passing driver captured on camera the moment a high voltage cable exploded. By the way, it is also in Russia. Another powerful explosion on the roadworks. Called the electricians. The excavator was quietly digging until it hit the cable, but to those around it looks normal. Subscribe for more. In this video, you'll see how dangerous.
So in the last short video, if you are posted at a place where there is an excavation, and say the excavator has got contact with the cables, electrical cables, what would be your reaction? How you save the person? Yes. Can anyone guess? Please mute your mics.
ବାହାର ବଢିଆ ଦେଖାଉଛି କିନ୍ତୁ ଟିକେ ହେଲେ ଭିତର ଫମ୍ପା କେମିତିଆ ଘର ବନେଇଛି କେଜାଣି
Please mute your mics.
ଗାଡି ସର୍ଭିସିଂ ଏଟା ଗାଡି ସର୍ଭିସିଂ ହଉଛି ବା କାମ ସରିଲାଣି ଏବେ
Tushar, please mute your mic. So I have a question. I'll repeat the question. If during the process of excavation, if your excavator or JCB is in contact with the high voltage underground cables, how you would save the person? Any idea?
Before doing any excavation, detecting is important.
What?
Detecting. There is
How
some
you detect?
Some detecting tools are there.
See, in India, it's very rare. Never in my service in India, I saw one company, even the bigger company, I'll not name the companies. Even the bigger companies don't have that equipment to locate the underground utilities. So what is the
Actually,
alternative
there is
method?
a DBMP and the local municipality approval has to be taken and identify the area risk assessment. Is there any cable going or underground cables are laid or not? There will be identification usually on the roadside.
Yes,
There
if
is
you
a-
have the municipality lines, then you can, as she has told rightly, but within the battery of your company, you should contact the electrical department. They will tell you the route of the cables. That's okay. But if if there is no, I see. This is the second video with related to my question. So be have patience. Now, how you will say? Just watch this short video.
If you contact the power line with your vehicle, call for help, stay where you are, and keep others at least 10 meters away from the vehicle. In the event of a contact, it is not just a vehicle, equipment, or object that could be energized. Everything within a 10-meter radius of the contact could also be energized. That's why you have to be aware of both step and touch potential. With step potential, electricity spreads, like ripples or rings, over the surface of the ground away from the point of contact. Each ring carries a different voltage. If you step into one ring while your foot is in another, the electricity will make up the difference in voltage through your body. With touch potential, if someone on the ground touches what is in contact with the power line, electricity will travel through that person's body to get to the ground. If you hit a power line, you can try to break the vehicle free of the contact, but only if it doesn't cause more risk to yourself or others or more serious damage to the power line. If you can safely break from the contact, move the vehicle or equipment at least 10 meters away to safety. If you must exit the vehicle, only in the case of a fire, jump away from the equipment with 2 feet together, then bunny hop or shuffle at least 10 meters away from the equipment.
So this is called the step potential or the touch potential. So for arc flash, you have zones. Keep this in your mind. It will never be marked. You'll have to assess depending upon the distance between the HT line and the person who is going to operate. So the white zone is safe. The green zone you can see, that is also safe. The yellow line is LRAP and the red one is the zone, danger zone. Now for a gas and oil and gas industry, can any one of you guess how the zoning is done? Or for industry where there is a possibility of high static current being generated in the production process, how can you zone this? Can any one of you guess? See, for oil and gas industry, there are 3 zones. Zone 0, Zone 1, Zone 2. In Zone 0, the danger is always there. Zone 1, it is less. Zone 2, it is 25-75. 25% it is dangerous, 75% it is safe. Then coming for production industry where dust, fine dust can cause static electricity discharge. Such zones we marked as 20, 21 and 22. 20 zone 20 is dangerous. 21 is less 50-50. Zone 21 is 25-75. 25% dangerous and 75% it is safe. Similarly, for arc flash, you have here different types of zones. Then coming to the effect of electricity, that is effect of current with 30 milliampere. Now here you see what if 30 milliampere current is passed through the body. There is rise in the blood pressure, laborious and irregular pulse. This is very important for the first aider. Unconsciousness, chance of ventricular fibrillation. This because if he gets a current shock of 30 milliamps, we go for what you call this AED. AED process where the electrical charge high current is given to the heart. Then you have the convolutions. Now safe voltage, what are the safe voltage guidelines? Under normal dry conditions, alternating current up to 50 volts, it is safe. But please don't take this as a grant. Then direct current up to 120 volts, it is safe voltage. So there you can see the difference between AC and DC current. So electricity, what are the measures that we can take for prevention? The first thing is physical protection that is used by use of the PPEs. The second one is the insulation of your electrical equipments or the PPEs. Double insulation, where do we have? Can one give example? Where you have double insulation?
In
And HT cable.
motors generally
Motor
we
with-
give the double insulations.
All the
Yeah.
DB has it.
Now most of the electrical equipment or the appliances are coming with double insulation, and you have a special mark onto that equipment which has double insulation. Plus, when an electrician goes for a high voltage HT line in works, we give him double layer of protection to his hand. Then ELCB, that is earth leakage circuit breaker. Then safety earthing and very low use of voltage. If you see America, that uses only 110 volts. But whereas to Asia and Europe, we use 220 volts or 240 volts. So first is the physical protection. Make live parts accessible by covering them with the non-conductive materials. That is why we go for insulation. The insulation can be of rubber, ceramic or plastic. Now double insulation, unearthed appliances, electrical appliances have two separate insulating layers. Now all those equipment or the electrical appliance that has double insulation have this particular mark. You can see on your chargers, on your mobile phones, latest electrical items such as micro oven, or it can be your iron, the iron that you use for your clothes. All these have this particular mark. That means it is double insulated. Then ELCB, the function of ELCB. It detects the earth leakage if a current above certain value, that is the sensitivity 30 milliamps more,
चलती तो 7.5 ରୁ 9.5 जाए.
it automatically switches off
अभी
the power.
तापरे
Must be
जो safety
tested regularly.
council
Offers
ଗୋଟେ member
no absolute safety.
ସେଥିପାଇଁ ଆଜି ଗୋଟେ
Does
Tushar
not
Kant,
protect
please
against
mute your mic.
overcurrent, heating up or short circuit.
Tell
Yes.
him, sir, to mute. Tell him to mute, sir. He doesn't understand or what?
Please, participant, unless you have doubts or if you want to ask question, please mute your mics. There's a lot of disturbance that is being generated. See here, ELCB, it is he is telling that it must be regularly tested. That is why a safety officer has a checklist with him. Regularly or periodically, according to the policy of the company, he takes the electrician and go for test, and he notes down all the points that he has observed. Then it says no absolute safety. You see, as we in our previous discussion, you people have told that ELCB, okay, it trips off, it cuts off the current, so it is safe. But this particular point says offers no absolute safety. What does this mean? And it also does not protect against overcurrent. heating up, or short circuit. So,
నీకు ఎప్పుడు ఫ్రీ ఉంటే వాడు ఫోన్ చేయి ఉందా అని చెప్పి.
ఏమండి మ్యూట్ చేయండి. See, in the last question I have asked, which one you will prefer, RCCB or ELCB? Now, as per this, ELCB has limited safe protecting system. So people would still you would like to go with this ELCB?
RCCB.
RCB. So you want to switch now?
No. Last time also I told you that RCCB.
Yeah, that's why I asked for what. So here is the just diagram how it saves the person. How ELCB saves the person. Yeah, difference between RCCB and ELCB. I'll tell you the main difference. Why I would not like to go for ELCB. The reason here, RCCB is independent of earthing system. That means even if you don't have proper earthing mechanism, it will definitely work. But whereas for ELCB, you should have proper earthing system. If your earthing system is working very fine, your ELCB will work. If it doesn't work, ELCB will definitely 100% it will fail. So that is the reason I will not use ELCB. Instead, I will use RCCB.
We are using both RCCB and ELCB
Which one?
in the panel. We are using both RCCB and ELCB.
See, that depends upon
The
your
circuit
company.
breaker.
See,
Yeah,
that
the
depends
circuit
upon
breaks.
the company. But if we use both, either one will work, not both. So ELCB saves a person from electric shock. It opens the circuit. It opens the circuit when it sends leak current, means if there is shock, automatically it will trip. Provided there is good earthing system here. Then this is the connection for your portable tools. Here he is. See, as I've told, if earthing is what you call RCCB is independent of what you call earthing. Okay. But when we use welding machines, definitely you go for local earthing of the body, and also you check the earthing of your electrical system. Okay. There are possibility that in absence of proper earthing, the RCCB will, or it may trip again and again, causing frustration for the welders. That is why we go for ELCB. Then this is the earthing system for porta cabins that is provided external, and this is within the system. It is not external given. So what is the purpose of now earthing system? The main purpose is to avoid the electric shock to the human body, avoid the risk of fire due to leakage current through unwanted path, to ensure that no current carrying conductor rises to potential with respect to the earth, that then it is designed for the insulation. Now, for a good earthing, what are the requirements? Earth connection should be, or it should provide low resistance path. Setting up and selection of protective device should be as such that it should operate fast and to cut off the supply. Now, I think most of you are working now. Do you tell me what should be the earth resistance value in your company? What is the maximum permissible limit that you can go for?
5 ohms.
5 ohms then?
At the
Any
maximum
other
limit.
answer? How much?
At the maximum earth resistance.
No, how much? How much?
0
Maximum
to
value?
5 ohms, sir.
5 ohms.
Yes.
See here we are telling the earth connection should provide low resistance path. 5 amps is very high.
It's 0 to 1 ohm, sir.
Yes. That is very good answer. A maximum 1 ohm is permittable. But depending upon the type of equipment and other things, the resistance value will definitely change. Now we'll see. Now types of earthing systems that is there. Wire or strip earthing. Most of our houses you have seen that. Rod type of earthing. This also you have seen. Pipe earthing. Rod earthing we go for welding machines and other things. Then plate earthing. Plate earthing you can see in this diagram. You can in the photo you can see there. Here, for a healthy earth pit should have a value as low as possible, that is 0.5 or 0 to 1 ohm. The lesser the earth has the resistance, the maximum current it can take up. So the potential rise is very low. Which one? Ankit, you want this particular point to be repeated? See, earth resistance value, how much it should have? For a healthy earth pit, like if you have in your house, if you have got a new one made or an old one, if you check the values, it should always be maximum 1 ohm. More than 1 ohm, it has less resistance to take up the power from your home to the earth. If it is less resistance, that means if your earthing system has less resistance, it will take up the maximum voltage, the leaking voltage to the earth. That is what it means. Ankit, is it clear?
Sir. Yes, sir.
Then allowable earth resistance. See, your question is in hill areas, it is above 1 ohms. See, terrain to terrain, it will definitely change. Okay, when you are designing your earth pit system, the values will change if it is sandy soil, if it is wet soil, if it is dry soil, or if it is rocky soil. The values will definitely change. Now, when you are speaking of hilly areas, the terrain geography of between the land and the hill will definitely change. In wet areas, it will be more different. In dry areas, it will be different. That is why it may be more than 1 ohms. Now 4 ohms is equal to electrical system, and for metallic structure, maximum some of our people have told 5 ohms. So here we'll see the different values. 7 ohms for storage tanks. 1 ohms for main earth grid and pipelines. That is why we go for grounding of the pipelines if that carry the flow of different types of liquids or gases. Then earth pit resistance, Raleigh's unit should be less than 1 ohm. So here, yes, this I'll skip because it is not required for you. Who is who? Yeah, static electricity. When two electrical neutral but different surface come in contact, they transfer the electrons from one surface to other. Both becomes electrically charged so that one surface loses charge and other will gain the charge. Now this is more prominent where you have the flow lines over there. Because of the friction of the flow of the liquid or the gas, the pipes develop the static current. To discharge that, we use earthing systems. one will become positively charged and other will become negatively charged, and the difference between them will will bring up the discharge, or the spark discharge will occur depending upon the strength. Then static electricity. Effects of static electricity. It can cause fire and explosion, discomfort and possible injury to the person who. Now, liquid gas flow lines, as we have already told, tankers, ducts, and vessels, they will develop static current. Now, how many of you are, if working in a pharmaceutical company, when the trucks brings the different types of liquid, what is the procedure that you follow while unloading of the truck? You got my question? If there is a truck with the raw material coming to your premises, how would you unload that? And what, as a safety officer, what precautions would you take for the tanker to unload?
Earthing
Earthing of what?
vehicle.
Yeah, earthing of
Sir,
vehicle and
sir, while entering the vehicle, there is a spark arrestor.
yeah,
So
that
the
is muffler.
spark,
Yeah, that is
uh,
muffler.
then
Spark
there is a
arrestor
lift.
or muffler, it is called.
There is a
Earthing
lift
body,
table.
yeah. The body of the truck has to be given earth, and to the vessel to which you are
Whether-
discharging also has to be earth. Both of them has to be earth. Then liquid and gas under pressure from the nozzles. That is why, you know, your sandblasting, when you are going for sandblasting, even the dead man handle has to be given earthing, and if you go for spray paints, even that particular part of your equipment has to go for earthing. Then dragging a metal container along with the insulated floor. This is movement of driving or the conveyor belts, because conveyor belts keep on moving. Even if you see, even that particular body is given earthing. The pneumatic conveying of the plastic pellets and blending. This you can see in steel plant and other manufacturing industries. Now, what are the protection methods? Now, bonding the earth of equipment and the pipeline that we have already told, provide adequate earthing to the body. Low velocity of fluid. Now, the more the speed of the fluid or the gas that is being discharged in the pipeline, the more static current it develops. So, if you reduce the flow rate, the friction will become less, and the static current that will generate will also become less. That is what it means. Use of anti-static material, that is insulation and other things. Wearing of anti-static shoes. If you have observed your safety shoes, it will under the sole, they will be written anti-static shoes. Use of a static discharge plate or the plant at the plant entrance. Then earth monitor to ensure the proper earthing static of the tankers. Just now we have discussed, when the tankers are discharging, you need to ground the body of the truck. Then now ionizing radiation. Now here there are two types of radiations. One is very strong and other may not be. Now, can anyone guess what these two types of radiations can be? Can anyone guess? See, the radiation here, you have two types. One is ionizing radiation and other is the non-ionizing radiation. Non-ionizing radiation is your UV lights, microwaves, or the electromotive for magnetic radiations, laser beam, sunlight, and other things. Whereas ionizing radiation is generally developed from the nuclear way or nuclear material, such as uranium, plutonium, and other things. Now here you can see non-ionizing and radiation. Exposure to non-ionizing radiation can damage one health, therefore measures. Read the instructions and the information displays on the appliances. This is more prominent with your mobile phones and your micro ovens. Respect the instructions pertaining to the duration of the use. Respect the prescribed safety distances. That is why when we say, when you are using your mobile phone, you need to have safe distance from your ear, but we don't follow that. Similarly, with your micro oven also, it is told that when you operate your micro oven, keep safe distance and close the door of the micro oven. Now here, this is the symbols that is used for non-ionizing radiations. Now, what is the radiation? Radiation is the energy that moves in the form of particles or the waves that we have already studied in our lower classes. And this, when we are exposed to those things, we get different types of health hazards. Now, with reference to non-ionizing radiations, that is mostly the electromagnetic radiations or the sound or the ultrasounds. Now here I'll show you the next picture different spectrum of radiations that is being generated. Electromagnetic waves at different frequencies cover different types of spectrum. Now depending upon this, it can be radio wave or that is RF, or it can be microwave, that is MW. Now here, depending upon the frequency of the radiation, it harms the people. Now here, if you see, this is the spectrum, electromagnetic spectrum. On to the right side, you can see ionizing. Ionizing, the lesser the wavelength and more frequency, such as the gamma rays, it damages more. Whereas to the left, if you see, the wavelength is more, the frequency is less. So the damaging capacity is also less. Now, understanding this non-ionizing radiations. Now, although the humans have used the radiations emitted from light and heat, the OSH professional has to understand the relevant exposures and the control strategies. Now, why for a safety officer it is important that even he controls the non-ionizing radiation? Can anyone guess? Now, this electromagnetic radiation in its frequency is always having a unit called that is the hertz. Now, here if you see in ionizing radiation, which one is more damaging? The gamma, alpha, or the beta? Which rays is more damaging rays?
Gamma rays.
Yeah, gamma rays is more damaging because it has lesser wavelength and a higher frequency. Now, radio frequency, although the definition is the radio frequency waves can be natural phenomena such as lightning and astronomical objects. OHS professionals are most likely to encounter artificially generated radio waves in radar, navigation system, computer system, and